For 15 years, every transistor in every advanced chip has been built the same way. A silicon fin, gripped by its gate on three sides, three fingers pinching a current. Then, in one July week, TSMC, Samsung, and Intel all confirmed the same thing. The fingers are done. The hand is closing. The 2-nanometer generation is not a shrink, it's a shape change. TSMC's N2 replaces the fin with stacked nanosheets, the gate wrapped all the way around. 1 quarter into volume production, it's already 3% of wafer revenue. Samsung's SF2 just taped out Tesla's AI5 chip, and the Taylor, Texas fab is spinning up to build it. Intel's 18A puts the same wraparound transistor inside Panther Lake laptops, ramping right now. 3 companies, 1 architecture, 1 moment. And it matters for one simple reason: the transistor's shape decides its power. And AI has made power the scarcest resource in computing. If you work in semiconductors or invest in them, subscribe. This channel maps who actually captures AI's value. So why abandon a shape that worked for 15 years? Because shrinking broke it. The channel is a hose and the fin's gate pinches it from 3 sides, but never underneath. Push the size down far enough and current leaks out the bottom on or off. Power vanishes as heat in a chip you're trying to cool. The nanosheet fixes this with geometry. Slice the fin into thin horizontal sheets, stack them, and wrap the gate around every side of every sheet. 4 sides, full grip. The leak path underneath is gone, and there's a designer's bonus. Fins came in whole numbers: 1, 2, 3 fins per transistor. A staircase, sheets have width. A dial. On N2, TSMC calls the dial NanoFlex, wide sheets where you need speed, narrow sheets where you need efficiency on the same die. The payoff: 10 to 15% more speed at the same power, or up to 30% less power at the same speed, and about 15% more density. Modest numbers until you multiply them by 100 billion transistors and a gigawatt of data center. Now, here's where the money moves. Start with TSMC. On this week's earnings call, it said customers have taped out 4 times as many 2-nanometer designs as 3-nanometer had at the same point. It's ramping 5 fab phases in year 1, across Hsinchu and Kaohsiung, plus a fresh $100 billion committed to Arizona for 2-nanometer class fabs and packaging. The ramp is so steep it shaves 3 to 4 points off gross margin this half. TSMC guided that number anyway. That's what demand certainty looks like. Reported early adopters: Apple, AMD, Qualcomm, Broadcom. Samsung is playing a different game. It went gate-all-around first back at 3-nanometer and paid in yield. SF2 is the redemption arc. The Exynos 2600 is already shipping in Galaxy phones, and Tesla's AI5 just taped out for the Taylor fab under a deal worth $16.5 billion. Samsung's wafer price, reportedly around $20,000, a third below TSMC's $30,000. And Intel? Its 18A stacks the same wraparound transistor, ribbon FET, on top of something neither rival ships yet: backside power delivery. Panther Lake is ramping now. Server chips follow. On that one piece, Intel is first. But the closed hand comes with a bill. A 2-nanometer wafer reportedly costs about $30,000, the most expensive standard silicon ever sold. SRAM, the on-chip memory that can fill half a modern die, barely shrinks anymore. Cost per transistor no longer falls automatically. That's exactly why TSMC accepts the margin hit to ramp faster, and why Samsung needs an anchor customer like Tesla, not just lower prices. And the next move is already visible: underneath the transistor. Today, power and data fight for the same crowded wiring on top of the die. Backside power moves the power grid to the underside of the wafer. Intel ships it today on 18A. TSMC's answer, A16 with superpower rail, is slated for 2027. Beyond that, the shapes just keep evolving. So watch 3 things: Taylor's yields on Tesla's chip, the pace of N2 through next year, and whose 2-nanometer class node lands the first big AI accelerator. Step back, and the story is simple. For 15 years, the race was shrinking the same shape. That race just ended. The hand has closed at TSMC, at Samsung, at Intel. From here, the winner isn't who changed shape first. It's who makes the new shape boring, repeatable, high-yield, wafer after wafer. That has been TSMC's identity for decades, but for the first time in 10 years, all three hands are on the table. If you want that map of the AI decade, subscribe. For the first battle of the 2-nanometer war, TSMC versus Intel, that video is on screen now.